I'm Rebecca McCabe from the Symbiotic Engineering and Analysis Lab at Cornell University, and I'm happy to share my talk today on value metrics and global impact potential of wave energy. So the motivation for this work is to better enable design convergence and to think about the strategic impact that wave energy may have. So design convergence is necessary for wave energy to achieve impact on a climate-relevant magnitude and time scale. And R&D in the next decade must strategically and systematically consider global impact in order to ensure our efforts align with our intent. So often we as engineers may zero in on a certain metric and pat ourselves on the back because our new design lowers the LCOE by 10%. But if we fail to think through the wider systemic implications, we could perhaps be doing so much more good by framing the problem a bit differently. Or in the worst case, our efforts could be outweighed by emergent system phenomenon due to unintended market pressures. And so that's why it's really important to look at things from a systems perspective. The ultimate question I want to answer is, what designs should wave community converge to, and what is the most effective R&D pathway to get there? And today, as an interim question, to help answer this ultimate question, I'll talk about metrics and markets. So what metrics should we use to evaluate the different designs and R&D priorities we're trying to decide between? And how do different markets influence this? Because different markets may have different metrics that need to be prioritized. So on the metrics, the question is, what metrics should we be thinking about that we currently aren't? The approach I'll take here is to consider metrics related to environmental, social, and economic impacts. This is also called the triple bottom line, or the intersection of people, planet, and prosperity. And then in terms of markets, one of the questions that yesterday at the end of the PBE session we were left with is, how do we know what lessons learned from PBE markets are translatable to utility scale? And one way we can think to answer that is, how much overlap is there in the value metrics for PBE markets compared to those of utility markets? And another question to think about is, will design convergence of a WEC optimized for PBE markets result in a suitable design for utility markets? So there are different types of metrics, and for optimization or any sort of other quantitative decision making, metrics should be independent, measurable, predictive, and relevant to what you actually care about. And so metrics can be categorized as leading metrics. Those include early exploration state proxies and the usual metrics, as well as lagging metrics, which are typically exactly what you care about, but lagging metrics are typically not predictive and so are used in the monitoring stage as indicators. Examples of what these metrics might be for the three types of triple bottom line impacts are, for example, shown here. So for example, we have the ACE, which is an early stage metric created in the Wave Energy Prize as a proxy for LCOE, and that's the ratio of the average climate capture width and a characteristic capital expenditure. And then if you look at the environmental column, starting from the bottom up, what we actually care about is the concentration of CO2 in the atmosphere. And that can be proxied for its effects with a single project as the global warming potential, or that's the equivalent CO2 intensity of that energy. And previous life cycle analyses for WECs have shown that marine operations is, the frequency of marine operations is likely a key contributor to the global warming potential. And then on the social side, it does become much more difficult to quantify things, but some sample metrics are shown for how we might look at energy equity across income. And so with these types of metrics, I'll now show for the rest of the talk the elements of an initial proposed framework. And so this framework is something that is going to be I'm going to be seeking feedback on and discussion of before eventually implementing all or part of the framework. So this framework for quantifying global impact contains 4 different modules shown here, and the framework could be used in 3 different use cases. The use case shown by the green arrow on the top is to evaluate different device designs and see which design may have the greatest global impact. The second use case shown in blue is to evaluate different research and development plans or priorities and where we should focus to get the most global impact. And finally, shown by the pink arrow, we could use this framework for, given a device with existing metrics, what markets might it be best used for. But I'll focus here on use cases 1 and 2 to evaluate designs and R&D plans. Going through the inputs and outputs of this hypothetical proposed framework. Device design inputs include standard things like what is the WEC operating principle, how is it controlled, its geometry, its power takeoff mechanism, and etc. The type of input used for R&D plans could be, for example, an allocation of research money to how much emphasis is put on each metric to improve it. Then for device metrics, this is where it really gets interesting. So in addition to the levelized cost of energy, there are levelized costs of other things like water or data collection that may be more applicable to PBE markets. And then there's also the metrics that relate to value. So while levelized cost talks about how much would we need to sell this electricity for in order to break even on our costs, on the other hand, levelized value of energy is about how much can we sell this electricity for, given the value that it gives to our stakeholders. And so this is, thinking about value is another, it's still in the economic domain, but is an important thing to think about when assessing metrics. And then the net value of electricity, NVOE, is the difference between LVOE and LCOE, and is considered by what I will report to be a more comprehensive economic metric. And then there are a variety of other economic metrics shown here. And then I'll jump to the environmental metrics. There's the EROI, the energy return on investment, things like the ecological footprint and the global warming potential that can all be used to evaluate environmental impacts. Then the industry growth metrics can include things like the number of devices deployed in each market. And finally, the output of the impact model would be global impact metrics. And so for these, we can draw on the work of other organizations. For example, the UN Sustainable Development Goals contain 233 quantifiable indicators, which track progress on the 17 UN Sustainable Development Goals. And a similar index is the Legatum Prosperity Index, calculated a little bit differently. And there are also metrics like the gross national happiness, which attempts to quantify the overall well-being of a population. And so in the next slide, I'll focus a bit more on the different sources of value that could be provided by marine energy or wave energy specifically. So value can come, in addition to just the economic value of the energy, from temporal value because of seasonal variation, especially in conjunction with other resources like solar, or the overall variation of the power. There could be value in the spatial because of proximity to population centers and proximity to the offshore blue economy devices that we may be powering. Then there's a variety of ilities like flexibility, reliability, resilience, and other. And so these things in some cases could be more difficult to quantify, and we could use conversations with stakeholders and stakeholder value networks to quantify them. Although in some cases, for example, reliability, there are pretty mature methods, for example, from the aerospace industry to quantify reliability of the system based on reliability of components and how those components interact. And finally, we can think about the functional value that wave energy may provide, for example, to dampen out the wave climate of the environment which is something that other renewable energy sources are not able to do. And so, given all these value streams, they would all go into the computation of device metrics in the framework. Now I'll get into each of the 4 modules and how they could be implemented. For the device simulations model, it's the most straightforward, containing typical engineering simulations, especially emphasis on taking into account multidisciplinary considerations. Another field that can be leveraged here is product family and platform design, which is a field that talks about, given a variety of market segments, what is the best strategic way to divide up a set of design families so that designs can be strategically reused across different markets and having the right level of scale for different markets that require it. And additionally, lifecycle analysis is a field that can be used to evaluate the environmental metrics. The next module is the technology learning curves. The field of technology road mapping can be leveraged here to help us figure out, given an R&D plan, what effect it may have on device metrics over time. And also parameter sensitivities from the engineering simulations can be leveraged to figure out what may be most impactful to focus on. Then, one of the more complex modules is blue economy growth forecasting. And so, at first thought, you might think that a linearized model might be useful. This would be something like, if, for example, the levelized cost of energy lowers by 10 cents, then we have an additional 100 renewably powered aquaculture farms. But something like this is often going to be misleading just because there is a lot of dynamics to account for in things like technology uptake and market growth. And so a likely more appropriate method to analyze this module would be the field of system dynamics. And that's from within systems engineering, using diagrams like the one shown to lay out the different inputs, outputs, and feedback loops in processes that especially involve people and are notoriously difficult to quantify. And additionally, economic models may be leveraged here. And finally, the impact module could be implemented leveraging the fields of predictive impact modeling and social life cycle analysis, and additionally perhaps more of the system dynamics discussed previously. And this model would say, for example, given for every additional renewably powered aquaculture farm, how much overall CO2 are we saving in the world? On the surface level, we could look at how much CO2 would be avoided from powering that aquaculture farm with diesel, but there's also a lot of knock-on effects. Like, we have to consider, for example, does the growth of aquaculture affect global protein consumption and take demand away from other more greenhouse gas intensive protein sources like livestock? And so these sorts of things will be very difficult to quantify, but are worth thinking about because these types of effects are often very large. And finally, some potential future work of what might happen to this framework going forward. The value metrics and requirements for PBE markets could be further developed, evaluated for independence, and looking at how similar the different metrics are across markets. The modules would be implemented with the likely bottleneck being the complexity of accounting for the blue economy growth and impact. Optimization could then be used to find the design family and research priority that result in the highest amount of global impact. And sensitivity studies could then be used with these results to inform the industry trajectory going forward. And I'll end with some questions for you for discussion. What challenges might you see in the implementation and application of this framework? Can the framework be simplified, or on the other hand, must more complexity be added for it to be representative? What other methods, especially from other fields, could be leveraged to improve the framework? And finally, how can we encourage researchers to consider the systemic impact of their work and to prioritize strategically whether or not this framework is adopted? And I'll thank the funding sources used in this work. Thank you.
quantify that the value. I think this is great. One major component that with your methodology is the systems engineering, the dynamic model. How do you suggest we actually approach that to build that model? Because that model is almost like the framework, the backbone of a lot of the moving part. And if that system is too simplified and it's not capturing the essential. If it's over complicated, then it would take forever for us to build that. So what would be a suggestion? What would be the path forward for that?
Yeah, so I think that for building this type of model, it would be smart to start with existing system dynamics models that are out there, because there are component modules for things that are commonly modeled across every field. Things like environmental effects of a product and technology uptake of a technology. And so starting from those backbones and then building there, especially in consultation with like lots of stakeholders, to adapt it to be the most appropriate for marine energy.
Thank you. No, happy to discuss more and see how can actually move that forward. Thank you.